Okay, so here's the last of the calculus until we get to applications. We'll start that tomorrow. So you need to make sure you get all these notes in your notebook. We talked about the rules of differentiation on Monday, and we wrote them down in our book, and then we worked a few examples, and we're going to continue working some of those examples. So find the gradient function of f of x equals x squared minus 4 over x. And remember, the gradient function is the same thing as the derivative. So we're going to look for the derivative. So the first thing we have to do is rewrite that so that we know we can take the derivative a little bit easier. So we're going to rewrite that as x squared minus 4x to the negative 1. Remember, we can bring this x up and just change its exponent, the sign of its exponent. So on the bottom here, it's x to the 1. We bring it up into the numerator and it becomes x to the negative 1. That allows us to take the derivative. Remember, to take the derivative, we take our exponent and we bring it out as a coefficient, and then we subtract 1 from the exponent. So our derivative here would be 2x plus 4, again, because negative 1 times negative 4 becomes plus 4, and then we subtract 1 here, so we get x to the negative 2. So we get 2x plus 4x to the negative 2. We rewrite that, getting rid of our negative exponents, and we get 4 over x squared. So that's our derivative. Now it says find the gradient of the tangent, the slope of the tangent to that function at the point where x equals 2. So all we do now is substitute into our derivative to find the slope of the tangent. At x equals 2, we plug in, instead of an x here, we're going to put a 2. So f prime of negative 2. So we get 2 times 2 plus 4 over 2 squared. And all we do is solve that. So we get 4 plus 1, which is 5. Because 2 times 2 is 4. And 4 over 4 is 1, so we get 4 plus 1. So the slope of our tangent to this function at the point x equals 2 is 5. Okay, so it says use technology to find the gradient of the tangent to y equals x cubed plus 3 at the point where x equals negative 2. So what you're going to do in your calculator, and if you don't have a calculator, you can come in for tutoring, or we can go over this problem real quick at the beginning of class tomorrow. But in your calculator, you're going to go into y equals, and you're going to put x cubed plus 3 into your calculator in y1, and then you're going to graph it. Then you're going to go to second and calculate, and we're going to go down to number 6, and it's going to say dy by dx. So we're going to calculate the derivative. And then it'll ask you to put in a value. It'll give you a graph, and you just type in negative 2 and push enter, and it will give you a value down at the bottom of your graph that says dy over dx equals 12.00001. So the slope of this line, the slope of the tangent to this line at the point x equals negative 2 is 12. And we could do the same thing without the technology. We could find the derivative, which would be 3x squared. And then all we do is type in the negative 2. We put negative 2 into our derivative. This is our derivative function. So 3 times negative 2 squared, negative 2 squared is 4. 3 times 4 will give us this 12. And then it says, if y equals 3x squared minus 4x, find dy by dx and interpret its meaning. So if y is 3x squared minus 4x, then dy by dx, we take the derivative, we bring this squared out, multiply it by our coefficient, and we get 6. 6x, and then 2 minus 1 is 1, so it's just 6x. And then there's a 1 for the exponent here. We take it out and multiply it by the -4. We get -4, subtract 1, we get 0. So our derivative is 6x minus 4. And to interpret that, we would say the derivative of this function is equal to this. At what point on the graph of y equals 2x squared plus 5x minus 3 does the tangent have a gradient of 13? So this is just pretty much working backwards. Again, we need to find dy dx. So we multiply 2 times 2, we get 4x, and then 2 minus 1 is 1, so that's just 4x. And then there's a 1 here, so 1 times 5 is 5. X, subtract the 1, and we get 0, and then the derivative of our constant is 0. So actually that x should not be there. I don't know why I wrote that. That should not be there. Okay, so we get 4x plus 5. So we want to know where the tangent has a slope of 13. So all we do is plug 13 in right here. So we get 13 equals 4x plus 5. We subtract 5 from both sides, and we get 4x equals 8. We divide by 4, and we get x equals 2. So wherever x equals 2 is where this slope is going to be 13. So now what we do is we go back to our original equation and plug this x value in, and we solve for y, and that'll give us our y coordinate. So we end up with 2 times 2 squared plus 5 times 2 minus 3, and that is going to be equal to y. So 2 squared is 4, so 2 times 4 plus 5 times 2 is 10, and then minus 3. So we get 8 plus 10 minus 3. So y is equal to 15. So the point where the gradient is 13 is 2 comma 15. 2 comma 15. The tangent to f of x equals 2x squared minus ax plus b at the point 2 comma 7 has a gradient of 3, and we want to find a and b. So first thing we want to do is find our derivative again. Find our derivative, and we get 4x minus a. Because this is a 1, we bring our 1 out, multiply it, you get minus a, and then we subtract 1, so the x goes away, and then b is a constant, so that's 0. So now we have to take our x value and plug that into our derivative. So 4 times 2 minus a, so we get 8 minus a. And that is equal to 3 because it has a slope of 3. So we subtract the 8 from both sides, and we get negative 5 equals negative a, divide by negative 1, and we get a equals 5. Now we go back and we know here that f of 2 equals 7, because when x is 2, y is 7. So we go in and we plug in that in the original equation, 2 times 2 squared minus a is 5, 5x plus b, and all of that is equal to 7 because f of 2 is 7. So we get 7 equals 4 squared, or 2 squared is 4, 4 times 2 is 8, minus 5x plus b. And x is 2. I don't know why I didn't plug that in. So we get 7 equals 8 minus 10 plus b. So 7 equals negative 2 plus b. We add 2 to both sides, and we get that b equals 9. Remember, y'all can slow these down anytime you need to, and rewatch them, pause them, all that kind of stuff. Okay, so equations of tangents. If we have a curve y equals f of x, if the point A, here's our A, has the x-coordinate of A, then its y-coordinate is f of A, just like we did before. If we have that A is 2, then the y-coordinate would be f of 2. And the gradient of the tangent at A is the derivative at A. So the equation of the tangent then becomes y minus f of A over x minus A is equal to the derivative at A, or we can rewrite that as just by cross multiplying. We can write that as y minus f of A equals the derivative f prime of A times x minus A. And that's just a formula that has to do with slope. So make sure you get these two formulas down in your notes. We're fixing to start applying those. And actually here on the next slide, we have them written really neat for you. It says the equation of the tangent at the point A comma B is y minus b over x minus A is equal to the f prime of A, or y minus b is equal to f prime of A times x minus A. And that's just the equation of the tangent line at a point. So find the equation of the tangent to f of x equals x squared plus 1 at the point where x equals 1. So we know that f of 1 would be 1 squared plus 1, which is 2. We now know that the point here, instead of just knowing what x value is, now we know the entire coordinates. We know that that the point of contact where that tangent is going to contact our curve is at the point 1 comma 2, because we found our y value by substituting in f of 1, because if our x value is 1, then our y value is f of 1 from the previous slides. So now that we know the point where it contacts, we find our derivative. So f prime of x is equal to 2x. And by now I should not have to walk through the steps, but we bring the 2 out. That becomes our coefficient. We subtract 1 and we get x to the 1, and then the constant goes away. So now we can find our derivative at A from our other previous slides where our formula is, and A for this one is 1. So we're going to find f prime of 1, and when we plug that in, we get 2 times 1, which is 2. So the tangent has an equation of y minus 2 over x minus 1, and that is equal to 2. So that's y minus 2 equals 2 times x minus 1. So we get y minus 2 equals 2x minus 2. We add 2 to both sides, and we get y equals 2x. So the equation of our tangent line is y equals 2x. All right, so we can use technology kind of in the same way. I want you to copy this problem down, and we will actually go over it at the beginning of class because it's using a new draw tool that we haven't done yet. So copy it down and leave yourself some space so that you can write the steps for how to do this type of a problem in your calculator. Now we're going to go ahead and we're going to work the problem. And we're going to work it the long way, and then we will go over it using technology and check our answer. So you've copied this problem down in your notebook, and while I erase. All right, so the first thing we have to do is find where x equals 2. We plug it into here, so we have f of 2 is equal to 2 cubed minus 7 times 2 plus 3. So we get 8 minus 14 plus 3. So we get negative 6 plus 3, which is negative 3. So our y value of that point is negative 3. So the point is 2 comma negative 3. Now I'm going to go ahead and erase this again. That way I can rewrite the next stuff. I don't know why this thing will not change so that it'll get bigger. Alright, so now we're going to find the derivative, f prime of x, which is equal to 3x squared minus 7. And then we're going to find the derivative at the point where x equals 2. So I'm going to put a 2 here. So we get 3 times 2 squared minus 7. So 4, 12 minus 7 is 5. So the slope is 5. So now we're going to take and we're going to do y minus negative 3 over x minus 2 equals 5. So then we get y plus 3 equals 5 times x minus 2. Y plus 3 equals 5x minus 10. Subtract 3 and we get y equals 5x minus 13. That is the equation of our tangent line. So now it says to consider the curve y equals x cubed minus 4x squared minus 6x plus 8. And we want to find the equation of the tangent to this curve at the point where x equals 0. So we're going to find f of 0. So we end up with 8. If we plug 0 in for all of these x's, all we end up with is 8. So our point is at 0 comma 8. Now we have to find the derivative, which is 3x squared minus 8x minus 6. Using our derivative rule, then we're going to find the derivative at 0, and we end up with negative 6 because all of those x's will end up going away. Now we simply plug it into our tangent equation. So we get y minus 8 over x minus 0 equals negative 6. So we get y minus 8 equals negative 6x. Add 8 to both sides, and we get y equals negative 6x plus 8. So that is the equation of our tangent line. And then it asks us, at what point does this tangent meet the curve again? So what we are actually going to do is plot these two graphs, one in y1, one in y2, graph them, and then go to second calculate and calculate the intersection. We actually just calculate where those two things meet, and it'll be at 2 points where they meet, where it forms the tangent, and then it will cross it again. And we want to calculate that value. And you should know how to calculate the intersection using your... Alright, normals to curves. This is the last thing in this section. So we have a normal to a curve is a line which is perpendicular to the tangent at the point of contact. So we have our tangent line that, again, we're still using at the point A, comma, f of A. So that's where our tangent line contacts our curve, and then now we're going to draw a line perpendicular to that. Perpendicular means it forms a 90-degree angle. So the gradient of the normal at x equals a is negative 1 over f prime of a, because they're negative reciprocals, and the gradient of our tangent, which we've been working with this entire time, is f prime of a. So the reciprocal of that, we change the sign and we put it on the bottom, so we get -1 over f prime of a. So that is the slope of the normal of that line. So it says, find the equation of the normal to f of x equals x squared minus 4x plus 3 at the point where x equals 4. So again, we need to start by finding f of 4. So we get 4 squared minus 4 times 4 plus 3. So f of 4 equals 16 minus 16 plus 3. So it's 3. So the point is 4, 3. Now again, the next step is to find our derivative. So we get 2x minus 4. And then we're going to find our derivative at point A, which is x is 4. So f prime of 4. So we get 2 times 4 minus 4. So 8 minus 4 is 4. So this is the slope of our tangent line right here. F prime of A is the slope of our tangent line. So then the normal still goes through this same point that our tangent line goes through, but instead of having a slope of 1 over 4, the normal has the slope of -1 over 4 instead of +4 because it's a negative reciprocal. So now we use this and our slope again, and we solve just like we would for the equation of the tangent line. We have y minus 3 over x minus 4, this is where the 3 and the 4 come from, equals -1 over 4. So we end up with y minus 3 equals -1 over 4 times x minus 4. So we get y minus 3 equals -1 over 4x, and then when we distribute the -1 over 4 times the -4, we end up with +1. Negative signs cancel, our 4's cancel. Add 3 to both sides, and we end up with -1 over 4x plus 4. So that is the equation of our normal. Last example, find the coordinates of the point where the normal to y equals x squared minus 3 at 1, -2 meets the curve again. So we're going to find our derivative. So dy dx is equal to 2x. Then we're going to find our derivative when x equals 1. So we're going to plug in 2 times 1 is 2. So our derivative at the point x equals 1 has a gradient of 2. So the normal would have a gradient of -1/2 because they're opposite reciprocals. So the normal has the equation y minus -2 over x minus 1 equals -1/2. So now we have y plus 2 equals -1/2 x minus 1. Y plus 2 equals -1/2 x. When we distribute that, we end up with +1/2. And then we add 2. So we end up with, or subtract 2, sorry, y equals -1/2 x. And then when we subtract this 2 from both sides, we end up with -3/2. So this is the equation of our normal. Now we want to know, where does it meet the curve again? So the same way we did the other one, we're going to put 1 into y1, our original curve. We're going to put our equation of our normal into y2. We're going to graph those, and we're going to calculate the intersections. And that is the end of this session. See y'all tomorrow.